Hello, my name is Derek Jeremiah Dave, and for today, me and my team members will be presenting about the Lab 4, which is latching relay. So, firstly, the group members are me, the second is David Tiong Lung Wei, and thirdly is Eric Teo Go Hing.
Good afternoon to Dr. Rafida. My name is Eric Teo Go Hing, CE 190109. Today I will present about lab number 4, latching relay. Okay. For question 5.1, this is the main ladder diagram. Okay. When the PB stop is turned off, as we can see, all the they are not have in output. Okay, when I turn on the start contact, the output will turn on. Okay, after that I turn off the start contact. As we can see, the output are still on. When I turn off the PB stop, all the circuit will be turned off. Okay. For the observation, the ladder diagram is constructed according to the diagram given in the lab. Next, when the PB start is turned on, the circuit will run, which will give an output at Y0. Then, when the PB start is turned off, the circuit will get an output because we have a latch at the network 1, which will give feedback. When PB stop is turned on, the circuit will not give an output. For the question 5.2, okay, as we can see, this is the main ladder diagram. Okay, when the PB start is turned on, the robot will turn on. Then, when the PB start is turned off, the robot will turn off, but the siren will turn on. Okay. When sensor X2 is turned on, the robot will not turn on, and the siren at Y1 will turn on. Okay. For the observation, when PB start is turned on, the output at relay M0 will turn on, which will also turn on the contact Y0. This will allow the robot to start working. Then, when the PB start is turned off, the circuit will be turned off, which means that the robot is still off. The contacts X1 and Y1 act as normally closed contact. The X2 is act as a sensor, which will detect if anyone is crossing the robots. Since the contact Y1 on the top is connected to the Y1 at below, it will turn on the contact Y1, which will interrupt the feedback and stop the robots. That's all from me. Thank you.
Hi, a very good morning to Dr. Rafida. So, before I introduce myself, my name is David Teo Lung Wei, CE 190146. So, we are from Group 2, Session 3. So, for this lab MRIB for Lab 4, which is lab title is latching relay, I'm doing for experiment procedure 5.3. And we need to load the program, run and observe the result. For question 5.3, it's about an automatic home garage is equipped with the sensor S1 that detect the approaching car and will open the garage until sensor 2 detect the whole body has safely parked inside the garage. Please design the system. So this is our main leader diagram. We show the network 1 is sensor 1, sensor 2, relay and relay. For network 2 is relay and garage door. So for next figure is sensor 1 is on condition. So if this one is on condition, the whole of the output of M1 will turn on. so the garage will open. So the green one is the mean on. So for sensor 1 X2, this is sensor 2 X2 is on condition. So it normally close contact, it will open its contact and will close the garage door. So in this situation it will close the garage door. So from our version in the figure above, for the main leader diagram, we need to cascade to open and close the door when a car is entering and exiting the garage door. So this is our main leader diagram. And then in the figure main leader diagram, when sensor 1 is turned on, the output M1 will turn on, which lead to on all the contact of M1. So that means this, when sensor 1 is on, all the contact of M1 all will turn on. Then this happens because when a car is entering the garage, sensor 1 S1 will set and make the output, which is the garage door, to open. This one. Then finally, when the car is fully inside the garage door, sensor 2 X2, this is sensor 2, this is wrong, sensor 2 X2 will become high, which will on the normally closed contact. Hence it will open its contact and will close the garage door as shown in the figure above. So it's a close one. So that's all for me. Thank you very much.
For question 6.1, so in a factory, one conveyor is used for apple packaging. At first, operator will be placed an empty box. Then start button is pressed. Apple conveyor start to move. Apple conveyor consisting of row of apples which is arranged accordingly. Sensor 1 will detect the presence of apple. The apple will fall into the box one by one. After 10 apples has been counted by the SD1, apple conveyor will stop and it is ready to be picked up by the operator. Use latching relay to design your program. So in figure here, this is the main ladder diagram. So let me zoom in that. This is the ladder diagram. So this is the button XO is to start the program, which is this one. So M1 is to input the relay and Y1 is the output. So the apple conveyor can be switched on. So here the sensor 1 or start button X1 is turned on the counter. The counter is set to 10 at S2. S2. Here S2, which means to indicates to 10 apples. Then the X1 is activated until the CO value reaches to 10. Then it is and then it activates the contact CO or C0 in the network 2. This means the apple conveyor is stopped. So here, this figure shows that the reset button for the counter is turned on to make the conveyor to continue to move and start new counting of apples. Means reset. So for the discussion, we have learned about the latching relay function in PLC programming, which will help us develop and learn more about PLC in the future. To replicate the circuit, we utilize the latching relay function. By sending a single pulse to the relay control circuit, a latching relay may control the circuit. In addition, it is controlled by two momentarily acting circuits that set and reset the relay. So in question 5.1, the circuit is built using the report image as a guide. We notice that the output relay acts as a feedback input in tandem with the start switch, as can be seen in the diagram, where the PB start and PB stop switches are turned off. All of the other switches turn on. Then, when the PB start is set to on high, all of the switches turn on except the PB stop, which is set to low off. Finally, when the PB stop circuit is turned on, all the switches will turn off, resulting in a low voltage. The usage of a latch in this circuit 5.2 and how it works follows. For example, in the third illustration in this question, we concluded that latching works by turning on PB start, which lets the robot to move rather than remain fixed. As seen in our previous diagram, when the sensor is activated, the robot will remain immobile and the siren will begin to sound. Because of the relay connected to the PB start, the latch even operates when the PB start is turned off. Furthermore, according to a truth table, when all of our inputs and outputs are in the low state, which is 0, none of them light up save the X1 sensor. which is typically closed. Then for the second circuit, all of the circuits are turned off except for the typically closed X1. So the switches in the third circuit will all light up since they are all in high state, which is 1. But the typically closed switch is in low state, which is 0. Finally, only the first sensor was turned on to test how it would react, but all of the switches remain low, and the second sensor was turned on because it was generally closed. In our lab for part 6.0 or 6.1, the start button XO will turn on the conveyor, causing the apples to travel as expected, and the sensor X1 will detect the existence of the apple and compute the quantity of apples till it reaches 10. The counter button CNT C0 will show that the 10 apples have passed the conveyor when it reaches 10. This will force the relay button to switch off, as well as the conveyor. To restart the operation, press the reset button on the X2 button. So for our conclusion is, to summarize what has been said so far, the MRIB Lab 4 experiment has taught us a lot about the role of latching relays in PLC programming. To be clear, this appears to be incredibly useful for students like us in the future as we create and learn more about PLC. We utilize the latching relay function to simulate the circuit based on the supplied job. A latching relay in further details allows the circuit to be controlled by sending a single pulse to the relay control circuit. Aside from that, it also controlled by 2 momentarily acting sensors that set and reset the relay. So for this is all our lab. Thank you very much.